Hey, welcome back. Thanks for deciding to watch the second video. Mr. Eicher here. We're continuing our notes in Chapter 1, Section 4, 1-4. If you haven't printed those notes yet, it might be helpful to do that. But again, if you don't have a printer, the printer's out of ink, then I'd encourage you to write down the question and then follow along. It's also helpful to pause me, even when I'm mid-sentence, to pause and see if you can figure out what would the next step be. I know it's really easy on videos like this just to kind of like watch and not take notes, or just like watch and think it all just seeps in, or maybe you watch and like write down every stroke of the pen that I make. But it's really helpful as you learn math to try to predict, hey, what's he gonna do next? What's he gonna write? How's this gonna happen? So I'd encourage you to pause the video before I start writing the next line and see if you can figure it out. And that's gonna really help your brain like grasp what's going on. And then when you get to assessments, you'll do that much better than you would have if you hadn't done that. So I'd encourage you to do that. All right, so let's get started. To solve absolute value equations, you must write two equations. I can't emphasize this enough, so I'm even going to highlight it. You must write two equations. We write two equations because, for instance, if we had the absolute value of x equals 3, x can be two different answers. A lot of times prior to this in math class, you might only get one answer for x, but in this case you get two answers. What could x be? Well, x could be 3 because the absolute value of 3 is 3. But also, x could be negative 3. The absolute value of negative 3 is also 3. So notice we get these two values for x. X could be 3 or x could be negative 3. So what I have here is, suppose we have numbers a and b is greater than 0. If the absolute value of a equals b, then we know two things. Either a is positive or a is negative. And that's basically what I wrote above. So we get this is true, but also we get the absolute value of negative 3 equals 3. So that idea that we get a positive and we get a negative, that, well, I said those in the wrong order. A positive is this one, and then a negative is this one. That's the positive one. So we're going to use this idea to solve absolute value equations. And I believe in Math 2, you solved absolute value equations. So here are the 3 steps that we'll be using. Number 1, we will isolate the absolute value equation. Now, some examples of what we mean by that. Say you had something like this: 2 times the absolute value of x equals 6. When we say isolate, we want the absolute value and the stuff inside the absolute value bars to be the only thing on one side of the equation. So the problem thing is this 2 right here. So we'd have to divide both sides by 2 to get rid of that 2. And then the yellow absolute value bars will be isolated. Another situation that we come across, say you have absolute value of x minus 5 equals 6. The absolute value bars and anything inside should be the only thing on the left side of the equation here. So the issue is this little minus 5. So we'd add 5 to both sides first. It's kind of an issue of order of operations. You want to isolate something before you solve and rewrite your two equations. And that is our second point. After we isolate the absolute value equation, number 2, we write, or we could even say rewrite. Yes, maybe I like rewrite better. Rewrite the absolute value equation into two opposite equations without absolute value bars. So again, I think I've written this a couple times already, but if we had the absolute value of x equals 3, we could say one of two things. We can rewrite this so that x is either 3 or x equals negative 3. So notice here I don't have absolute value bars anymore. I just have x. But I do have a positive one and I have a negative one. So that's basically the approach that we're going to take when solving these. And then third, it's important to check your answers. It's important to check your answers because you could have one solution, you could have two solutions, or you could have 0 solutions. So the most you could have is 2, the fewest is 0, or you could have one solution. So that's the importance of checking your answers. But really all of these are really important steps. So that's why I wrote them out here, step 1, 2, 3, in that order. So let's check out these absolute value equations. Solve, check your answers. So the first thing, this is number 5, the first thing I notice is I need to isolate. So notice this 2 right here is on the outside of the absolute value bars, so I need to deal with that too. So I'm going to divide both sides by 2. Divide by 2, divide by 2. And that divides those 2's out, and we're left with, on the left, b plus 4 in absolute value bars equals 48 divided by 2 is 24. Okay, so that was step 1. We have isolated the absolute value bars. Step 2 is rewrite this as 2 equations. So we're going to, so this was step number 1. Step number 2, we're going to rewrite it as 2 equations. So we're going to have b plus 4, no absolute value bars, b plus 4 equals 24. That's one of the equations. Or b could be something else. The second equation, we're going to have b plus 4 equals negative 24. And I'm going to highlight that negative because that's really important there. The only difference between these 2 equations is the one on the left is positive 24, the one on the right is negative 24. And then we'll solve. So solving, we would have, wrong one. Solving, we would have subtract 4 from both sides, so we get b equals 24 minus 4 is 20. And then equation on the right, we'd have b equals subtract 4, so that would be negative 28. So we get these 2 possible answers. I'm not going to circle them yet because I should really check my answer. So maybe I'll do that in red over here. Check. So I'm going to plug 20. First I'm going to plug 20 into the original equation. So I have 2 times the absolute value of 20 plus 4. Does that equal, question mark, does that equal 48? So solving that, we'd have 2 times the absolute value of 24. Does that equal 48? The absolute value of 24 is 24, so we have 2 times 24 equals 48. That's true. 48 equals 48. So I can circle this one. This one is a valid answer, and then I guess I'm writing kind of small when I zoom in like that. And then the next one we would have, the next one we would have is checking negative 28. So we have 2, plug negative 28 into the original where the x was. So that would be 2 times the absolute value of negative 24. Does that equal 48? Well, the absolute value of negative 24 is positive 24. Does that equal 48? Yes, it does. 48 equals 48. So we can circle this one. So we get 2 answers. 20 and negative 28. So that's it for that. Let's look at another one on the next page. This one right here. I'd encourage you to pause the video at this point. See if you could figure out the first step. See if you can determine, is the absolute value bars, are they isolated? The absolute value bars are isolated. It's just right here. Here are the absolute value bars. There's nothing out here or out here. Everything's on the inside of the absolute value bars. So step 1's already done. It's already isolated. Already isolated, smiley face. So the next part, we're going to jump to step number 2. Step number 2 is rewrite or write 2 equations. Is step number 2. So to rewrite that, the first one we're going to have, we drop the absolute value bars, and just rewrite everything on the right side as it is. That's identical. All that we did was drop the absolute value bars. The second equation that we're going to write the x plus 6 again, but this time we're going to do the opposite of what was there to begin with. Notice I use parentheses there. Since we have a difference of two terms, we have to be careful to distribute the negative to both terms. So now when we solve on the left, we'd get, let's see, maybe I'll subtract x from both sides. Let me show you some intermediate steps here. I'm going to subtract x from both sides. So that gives us 6 equals 2x minus 2. Then I'm going to add 2 to both sides. That gives us 8 equals 2x. Divide both sides by 2, so x is 4. We'll check that in a second. Or we would have, let's distribute, on the right side, let's distribute the negative. Then we'll subtract x from both sides. That gives us 6 equals negative 4x plus 2. I'd encourage you to pause the video, see if you could solve from there. But we'd be subtracting 2, 4 equals negative 4x. Divide by negative 4, so that would be a negative 1. So we get two possible answers, 4 and negative 1. So let's do our check. We're going to plug 4 in to the original equation, wherever the x is, right there. Does this equal? And we're going to plug 4 into that x as well. So that would be the absolute value of 10. Does that equal 12 minus 2? Well, the absolute value of 10 is 10. 12 minus 2 is 10, so that checks. So we get x equals 4 is one of our answers. And then do the same on this one. Let's check this one. So we would have the absolute value of negative 1 plus 6. Does that equal 3 times negative 1 minus 2? This would be the absolute value of negative 5. Does that equal negative 3 minus 2? The absolute value of negative 5 is positive 5. Does that equal negative 5? Wait just 1 second. Something's wrong here. I can double check my work first that I didn't make any mistakes, and it doesn't look like I did. But this is not true. If this is not true, then we call this answer, this is a no solution. This is what's called an extraneous answer. An extraneous solution is one that we think works. We didn't make any mistakes. We got it as a possible answer. But when we actually check it in the original equation, it doesn't actually give a true statement. Let me show you graphically what's happening with that number 6. Here in Desmos, I graphed the absolute value, ABS, absolute value of x plus 6. That was the original equation on the left side of the equal sign. And you get this red kind of has a corner absolute value graph. And then on the right side of the equation, it was 3x minus 2. So I graphed that. That's a line with a slope of 3 and a y-intercept of 2. So that's the blue line. Notice they only intersect at one place, and that place is x equals 4, comma, positive 1. They don't actually intersect at that other possible solution of negative 1. So there's no intersection down here. So really, where do these two lines intersect? They only intersect at one place. So that's just verifying that we only get one solution. And that's kind of a graphical way of looking at it. If I gave you these two graphs and asked where do they intersect, I don't think you would say they intersect at two places. Like, it's pretty obvious they only intersect at one place. So that's how we can have one solution for this particular equation. So we get x equals 4 is our only solution. X equals negative 1 is extraneous. You know, maybe just for kicks, we'll do a little. We'll include in your notes a little graph, if I can remember what those graphs look like. One of them was like this. That's the absolute value graph. And then the other one was like something like that. And then they only intersected here at x equals 4. Only one intersection. So that's why that one only has one solution. All right, let's move over to number 7. Now, if you'd like, I challenge you, see if you can answer number 7, do the whole works, see if you can isolate, rewrite two equations, solve, and then check your answers. So the first step we should do, I notice that this -2 here, we need to isolate the absolute value bars. Here are the absolute value bars. So we're going to divide both sides by -2. So we get the absolute value of 6x minus 1. That equals -2. And then, so that was step number 1. Step number 2, we'll rewrite or write two equations. E, Q, and S as equations. So we'll rewrite this as 6x minus 1 equals -2. That's the first equation that we write. It's identical other than we've dropped the absolute value bars. Or the second equation that we write is 6x minus 1 equals +2. I'm going to put a little plus there just so you could see something changed. It was -2, now it's +2. And again, that's based on the definition of absolute value. And then we'll solve the one on the left. We get 6x equals, let's see, add 1 to that would be -1. So x equals -1/6. On the right side, we'd have 6x equals, add 1 would be +3, so x equals 3/6. So x is 1/2. So these are my possible solutions. Let me do my check now. I'm going to take the -2, absolute value of 6 times -1/6 minus 1. Does that equal 4? So we have -2 times the absolute value. 6 times -1/6 is -1. Does that equal 4? So we have -1 minus 1, -2 times the absolute value of -2. Does that equal 4? The absolute value of -2 is +2. So we have -2 times +2. Does that equal 4? That is not true. -4 does not equal +4. So this answer we would say is extraneous. It looked like it was going to work, but it actually doesn't. It's not actually a solution. And then let's check the 1/2. So I'm going to plug in 1/2 into my original equation. 6 times 1/2 minus 1. Does that equal 4? So we have -2. Absolute value of 6 times 1/2 is 3. Does that equal 4? -2 times the absolute value of 2. Does that equal 4? And that would be -4. Does that equal 4? That is not true. Another one that's not true. The plot thickens. This also is an extraneous solution. I need an E in there. Extraneous solution. Let's look at a graph again to see why this makes sense. In Desmos, I'll go -2, absolute value of 6x minus 1. So that's my graph way down there. That's the absolute value graph. And then the right side of the equation is 4. Guess I need y equals 4. So if I asked you, where do these two lines intersect? Where does this graph intersect with this graph? I hope you would say nowhere. It never intersects. So that just verifies that we're not going to have any solution if those two lines don't intersect. There's another way at the very beginning that you could have told that we're going to get no solution. Let's go way back to this step right here. This is something that will be really helpful for you to observe. At this step, we have an absolute value on the left equaling a negative number. That right there is impossible. And the absolute value, if it's isolated, the absolute value cannot equal a negative number. So at this point, we would know there's no solution. So all this work that we did down here in blue and red, the blue work and the red check, we could have basically avoided all that work. I didn't want to avoid it at the very beginning because I wanted you to see that you do get not true things, you get both are extraneous, but we could have told that way at the beginning because of an absolute value equaling a negative is not possible. So those are a couple examples. We'll do one more example together, and then you'll do number 9 and number 10 as part of your Schoology assessment, your Schoology TT 1.4. Try this 1.4. So let's look at number 8. Number 8 is already isolated, the absolute value bars. There's nothing to the left or to the right on this left side. So we're going to jump right down to step number 2. Step number 2 is write or rewrite 2 equations. So the first equation, we have 15 plus m equals negative 2m plus 3. And the next equation we're going to have is 15 plus m equals the opposite of that. So I'm going to distribute a negative. I'm going to switch both signs. So now it's positive 2m minus 3. So right here, I distributed a negative. I write that because I hope it's helpful for your notes to have something like that. And then we solve. So we'll solve and check. Let's see. I guess I'll subtract m from both sides. And then subtract 3 from both sides. So that would be a negative 3m. This would be a 12. So we get m equals negative 4 is one possible answer. Don't want to circle it yet. I haven't checked it yet. And then same thing on the right. Let's, I guess I'll subtract m from both sides. Now add 3 to both sides. So that gives us 18 equals m. Well, that's nice. So those are my 2 possible answers. Now let me do my check. In the very original, wherever there's an m, I'm going to put my possible answer of negative 4. So we have the absolute value of 15 minus 4. Does that equal negative 2 times negative 4 plus 3? So we get the absolute value of 11. So that's just 11. And that's 8 plus 3. 11 equals 11. That's true. So I'm going to circle that. That is one of my possible answers. And then I'll do the check on the other side. Check. Put in an 18. Absolute value of 15 plus 18. Does that equal negative 2 times 18 plus 3? So on the left side it would be positive 33. And on the right side I get negative 36 plus 3. Does 33 equal negative 33? That is not true. So that means this 18 is extraneous. So I'm not going to circle that 18. Let me show you one more quick graph to illustrate this. This only has one solution. So let's go back here. We have in Desmos, absolute value of 15 plus m. Well, it's kind of a flat line. I guess I'll use it. 15 plus m. Whereas, oh, that was my y equals 4 line. Negative 2 m plus 3. Let me put y equals both in there, so I have equations I'm graphing. Notice how many times these 2 lines intersect. They only intersect one time right there. And notice the y coordinate of where they intersect. That y coordinate is negative 4. And as we indicated here, we only get one answer. These two, this left side would intersect with this right side at one place at negative 4. Thanks for watching this video. Hopefully it was helpful. You're going to do number 9 and 10 as part of your Schoology Try This questions. If you like the video, give me a thumbs up. And let me know if you have any questions. Let your teacher know if you have any questions. Have a great day, and I'll see you next time.